Hello everyone. In this video, I would like to discuss how can we implement the sequence control by using case instruction and use the Beckhoff TwinCAT3 software to implement this sequence control. This is a BK11 video. In the previous video, BK10, I briefly introduced how can we use the ladder logic and the structure test in the Beckhoff TwinCAT3. With this BK10 and this video BK11, basically you can use these two videos to implement the simple automatic control logic and automatic sequence control. And in the TwinCAT3 Beckhoff system, the common programming language that is a structure test. The most common way to implement the sequence control to use this case instruction, like shown in the screen. Another common way to implement the sequence control that is using the ladder logic. I will use another video, use the Siemens TI Portal and the 1200 controller as the base and show how can we use the ladder logic to implement the sequence control by using ladder logic. As we know, the sequence control is a common control structure. I prefer calling it structure because once you build up this sequence structure in your program, basically you can use the similar structure for multiple projects. And for different project sequence, like the right side, according to the different parts sequence or timing chart, you can reorganize, use the different step number to control the different object. So this allows you automatic sequence control very flexibly and very clear. And according to the different control, so this area can be reorganized. This structure can be modularized and reused for multiple objects and multiple sequences. So your program can be modularized and can be migrated or transferred to different projects very easy. To better understand this sequence control, I will use this housing crimp this process as an example. We can imagine to make this part, firstly, the operator will load this housing in the machine. Once this part present in the machine and the operator press a pump button, the machine will load this pieces parts in this housing. And after this, the jaw of the clamp will hold this part. And after this clamp hold the part, so the press will from the top to down to press this part to crimp this housing. And after this, maybe another additional process. For example, the heater or the puncher will do some additional process on this part. Eventually, by the timer control or by the sequence control, all the things will go back to home position. So the assembly of this part is completed. Without using the sequence control, you could have a multiple way to implement this sequence or implement this automatic process. For example, you can use the cylinders at work or at home to control the next cylinders or next object to go to work or go to home. However, that will cause your system a little bit mess. Or if this process stops in the middle, by some reason your sensor cannot turn on or this part present got something wrong there. So your process stuck in the middle. Basically, without this control, without this sequence number, it's hard for you to figure out where the process stops, how I can diagnose my system. So you can imagine if we use this sequence control, this sequence control has a number. This number is an integer number. Once this process stops somewhere, you can go to find out that integer number and go to find out where this procedure stopped and find out what the reason causes the procedure can now move to the next step. So it's very easy for the operator, maintenance, or the developer specialist to figure out what's going on of this system, how we can troubleshoot and find out the source of the problem as quick as we can. So personally, when I program the automatic control, most of the program structure I will use this sequence control. Not only for this assembling process, and we can take this timing chart as an example. This chart comes from the communication control between the PLC and the Keyence SR2000 barcode reader. To read the barcode from this barcode reader, PLC need to send a read request to trigger this barcode reader. And after this, barcode reader will give a response. trigger busy. And also at the end of this process, a PLC need to send this read complete clear to give the signal feedback to the SR2000. Let the SR2000 know, okay, this whole process is done. So this signal will use to clear this read complete signal to get it ready to the next trigger. So this is the timing chart for this trigger and reading. The timing chart can be separated into the different steps, and then we can use the step number to control the signals. If your customer asks you to program an automatic sequence, basically they will provide you this timing chart or the sequence description. The sequence description will be like this, but the timing chart will be like this style. Basically, we can use the case of this programming language to program the flowchart and this timing chart. When we implement the sequence control, basically in the program, we have two main parts. The first part, that is a sequence structure. The structure will allow this sequence move step by step, and the conditions to move the next step will be a common structure in this sequence program. I will show how to program this sequence structure at first, and then we will move to the cylinder or valve control area. This is the object control. You can imagine to control this cylinder A turn on to turn off or turn to work position or home position, we need to send the work cue output to turn on or send the home cue to home this cylinder. So the cylinder control will have a specific program to control this area. And after this, to allow the cylinders to be controlled automatically, we will connect the conditions from this step, this sequence with the valve bank. Connect the automatic conditions to this cylinder's automatic control. Basically, allows this cylinders can be controlled by this sequence number. There will be two main parts. In this video, I will mainly talk about the left part, that is the sequence structure. And next video, I will discuss how can we combine the step number to control the valve banks. Alright, let's go to the TwinCAT3. This is a TwinCAT3 software, and the current version I'm using, this is a 4024.7. And I already built up this project. To learn how to build up this project from the scratch, you can review my previous video. I will paste the link under this video. This is an empty project. Currently, we only have a main here, and this main is empty. From this POU, I will set up two individual programs. One is a sequence control, one is a valve control. Right-click, click Add, click this POU. And now this is a program. And firstly, I will set up that sequence control. We will select Structure Test. And next one, I will set up, that is a valve control. So basically, these two programs will represent this two area. The left area, we will use the sequence control to program this structure. And the valve control, we will program the valve control under the valve control program. In this video, we will mainly talk about the sequence control. Let's create some important tags from this GVL, and let's click this global variable list. For the sequence control, I will program SEQ. So all the important tags according to this sequence control structure, I will create or define that tag under this SEQ sequence page. Let's create the tags within this area. Okay. Firstly, I will declare one integer tag, that is I sequence step. And next one, I will declare this sequence step description, that is string. This string will be used to display string to show what the actual job or what the actual task at every step. For a production wheel, this description, this string value will be easy for the operator or for the user to look at what the current step is at. So I can write the comments at here. So this used to display the production task. Okay. And other than this, I will create 3 important tags. I will create other 3 arrays. So the first one, sequence step n task done. This task done will be used to control the sequence move to the next. And this task done delay timer, that is one array based on the timer. This task done delay timer will be used to have a delay and interval time between the current step and the next step. Sometimes we do not want between the one step to the next step, the program move too fast, because sometimes the mechanical things need a time to calm down or need a time to engage totally. So sometimes between the step to step, we can put a 200 milliseconds delay, especially for the commission wheel at the beginning of the test. We want to set this timer to 5 seconds or 2 seconds. So it's very clear we can see that step from one step to next step, because the interval time between the previous step and the next step, that is 5 seconds. You can clearly see this step done, and after seconds is moved to the next. It's easy for you to diagnose or to check out what the current status and any other devices. Okay, and this, after this timer done, I will use this task done, delay done. And once this timer expires, so I will use this bit to turn it on. If the step needs this timer to move to the next step, I will use this delay done to trigger move to the next step. Okay, you can follow this way to declare those tags. Alright, let's move to the sequence control. Alright, we will use the case instruction to implement this sequence control. To create a case structure, so we can type in case. And firstly, here we will use the integer number. The integer number will be used to index this case step. So the integer number comes from seq dot the step number. Okay, this is a sequence step number. The prefix, that is I, that means that is the integer. This is my tag naming style. Okay, and after this, we need an off here. So the system will automatically create this and underscore case. And within here, we will program the different number here. For the first step, we can name 0. Okay, and we can type in some comment here. Firstly, we can call this number will be used to initial. At the initial step, the operator will load the housing into the machine. And once the part present, so after the palm out button press, so the machine will move to the next step. So to program this structure, firstly, I will program to show the current step description. We can use the sequence description here. So the sequence step description, that is a string, equal to a string. We can temporarily type in an empty string here. We can type in after. Okay, once this case reaches 0, is waiting for some condition to move to the next step. The conditions may come from different conditions from outside. For example, sensor at home or other conditions. To gather all these conditions together, I will use the condition summary from this step 0. So I'm using the seq dot. So this bool be sequence step n task done. Because we are at this 0, this step, so I will use the 0 item. Because it's a sequence step number task done come from this bool array. Okay, we will receive couple conditions here. Okay, we haven't finished this program yet, so I will temporarily put this temporarily comment this line out. I'm going to set up a typical structure for each step. After we set up the entire structure, I will delete this comment and program the actual condition behind this tag. And after this, that is the actual status to move to the next step. So we will use that timer delay done. If you do not need that timer, we can set the timer to 0. If we need a timer, we can set a timer value. To make this structure similar, I will use the timer done signal as a condition to move to the next step. Here, I will use the timer done signal. Is this value, the sequence step task done and the delay done at 0. Okay. And if this signal turn on, that timer expire, we will move to the next step. That next step value is this value. I will control this value to next step. Okay. This is one typical structure for an individual step. Once the case starts from 0, it reaches this step. So the case will only focus on this logic within this step 0. And this string description will be used to store the actual production sequence description. And this tag will be used to control this whole step move to the next step. The next step, we will use the similar structure. For example, we can type in the next step, that will be the 1. The next step, we will implement another steps. And next step, we will use this bracket 1. And the task done, delay done, will be used net 1. And after the condition reach here, to allow the logic move to the next step, so we will move to the number 2. If you want to jump to another step, you can type in the step you want to jump to. Okay, so this is step 1. But most of the time, for my style, I will not use the next step from number 1. Personally, I will prefer use the next step at 5. I will use a 5 at a step 5, 10, 15, 20, 25, 30. As we know, the scope printing happens in every project. So using this 5 step from the current step and the next step, we have a 4 steps, spare steps here. So if the customer asks more additional tasks between the steps, we can use that 4 spare step to program others. Okay, go back to here. The next step, I will prefer to use 5. So from this 0, we will jump to 5. Okay. And at here, I will change to 5. From this 5 to move to the next step, I will type in, let's move to 10. Okay, for the step 10, we will program the similar way. Okay, this step, we will use the 10. Okay, so this step condition, task done, the index is a 10. This done is a 10. And from 10, we will move to the 15. Okay, use a similar way, we will program the 0, 5, 10, 15, 20, 25, 30. And from 20, we will move to 25. Okay, we follow the similar way and program this structure. As we can see, when I program this structure, currently it doesn't have any information related to the actual task. So that means this structure can be used for multiple purposes. So can be used for multiple task structure. It's kind of like a template. So you can use this as a template for your different job. And let's go back to this structure here. So as we can see, the step from 0, 5, 10, 15, 20, 25, 30. And once we reach to 30, we go back to 0. Basically allow this run as a chain, move to the top. So that means at the end of 30, if some conditions reach at the step 30, the sequence will move to the 0. So if we go back to here, once the 30 reach here, and once it's a 30, this timer task done. So we will move this step number, move to 0. Allows the case will index this 0, move to the top. This allows this whole chain can move as a circle. Okay, so I will change this number to 0. Basically, we finish this task. And then next step, we will program. So as we know, this is the condition at this step. And this step will trigger the timer. And when the timer reach and expire, so this delay done will turn on. This allows this sequence move to the next step. So where we can implement this timer here, we need to program something for that timer. To implement that timer, it's highly recommended you do not program the timer within the case. You need to program the timer out of the case. That's because, as we know, the case language will only focus on the step it adds. Once it jumps to the next step, the timer or some logic here will be skipped. So if you put a timer here, if the case off, move to the next step, the logic in the previous case, that will be totally hung up. So the timer will totally lose control. So that's why to implement the timer, it's highly recommended we implement the timer out of this case structure. Okay, so I will specially program another method under this program. So from here, I will add one method, and I will name it sequence conditions. Still use the structure test. So from this sequence control out of this case, okay, I will call this sequence conditions. To call this sequence condition, I will call sequence conditions bracket sequence conditions. I will call this sequence condition. It is here. Okay, once you click this sequence conditions, we need to program that timer control here. Okay, that timer control would be the similar structure for all other steps. So firstly, let me program the first step. So we will use one timer. So to call the timer, we can use this right-click mouse and click this input assistant. Use this instant calls. And if you recall, we declare the timer under the SEQ, this page. We go to find out GVLS, this folder, and find out SEQ, and find out the timer instant, FB, sequence step N, task done, delay timer. Expand this, and because the timer, that is a 100 array there, so I will click this, click OK. So it will automatically create this structure. So we do not need to manually type in this interface in, out here. The system will automatically show up all of this. The first timer we will use, that is 0, because the step will from 0, 0, 5, 10, 15, 20, right? So the first timer I will type in here. And then the input of the timer we will use that SEQ, that is the condition SEQ, that is the condition of that task done. And that task done also come from an array, so we need to use the index 0. 0 is related to this 0 timer. And PT, that is the time between step to another step. Initially, I will prefer to set time is 2 seconds. From one step to the next step, we will force this time to delay 2 seconds. So allows us to see very clearly from one step to the next step. We will see 2 seconds, 2 seconds, 2 seconds there. Okay, the output, we will use another bit that comes from SEQ dot this delay done. This delay done. This is another bool array. Okay, I will type in that is the 0. Okay. So for the Q, that is the output of this timer. So we will use SEQ dot this delay done. This delay done is also a bool array. So I will click and use the index number is also the 0. So this whole line, they all index at 0. The ET, that is the time left. From this sequence test wheel, we will not use this ET. So I will delete it. Leave this empty. So this timer now, it shows this red wave here. That's because to use this global tag, we need to type in this prefix name, SEQ. So I need to type in this SEQ prefix name. Okay, same thing. Okay, so let me enter. This condition will use to trigger this timer. After 2 seconds, this queue, this task done, delay done will turn on. If we go back to the sequence, that means this task done will be controlled by the conditions here. Once those conditions meet, so it will trigger the timer behind. After 2 seconds, this timer will control this task done, delay done, turn on. Once this turn on, this step will move to the next step, number 5 step. Okay, and this timer will be used as the one of the structure of this case or this sequence control. That's why I call this sequence conditions under this case. And note, we cannot program the timer within this case step. We need to program the timer control out of this case. That's why I specially organize this timer within this sequence conditions and call this sequence conditions out of the case. And same thing, we will follow this structure, program other steps. Okay, so we finished this structure. And this structure can be used a common structure attached with this structure control. So if you have another sequence control, you can use the similar way to program this timer here. Okay, so we prepare 0, 5, 10, 15, 20, 25, 30, and default time of those timer, that is 2 seconds. They will be used a transition timer between step to another step. Okay, till here, we basically finished this sequence control structure. And to demonstrate how this sequence control runs, and to demonstrate how this sequence control runs, I will download this program and I will trigger this task done, this bit, to demonstrate once we meet these conditions of this task done. So the sequence will move to the next step. And once this turn on, it will move to the next step. Okay, I will download this program, and currently I'm using this TwinCAT3 within one virtual machine, and to allow my laptop to run this TwinCAT3, basically run as a simulated controller, I need to use my virtual machine to run this program. And to allow my virtual machine to run this program, firstly we need to go to this real-time, this setting. Let me click this build solution. So it shows a 0 error. Okay, and then let's go to the system and find out this real time. And you need to click this read from the target. So it will read the courses from your laptop. And then you need to select the isolated core, because the TwinCAT3 need to use one isolated core of your CPU to run as a simulated controller. Okay, so I click this read from the controller, select this isolated, and then click this set on the target. And after this set, it allows you to use your laptop to run as a PLC controller. Okay, so I already implement this. Also, we need to make sure the license is not expired. So the beautiful things of this TwinCAT3, we can use the 7 days trial license. You can click this 7 days trial license and type in the letters here. Once you type in the same letter and click OK, the TwinCAT3 will give you 7 days trial license. This allows you to test some function and program without any pay. So now, firstly, I need to click this downstairs, activate this configuration. Click this start. Okay, this step will download the hardware configuration. This hardware configuration is very simple. Basically, this PLC is one empty project. We just set up the program only. So once we download this hardware successfully, you will see the one yellow running in this green square. So that means your simulated controller is running now. Okay, after this, we are going to download the program. Okay, meantime, let's go back to the main. Okay, so I missed one thing. So from the main, we need to call this sequence control. Also, we need to call this valve control. Currently, we haven't programmed valve control yet, but we can still call this valve control to prevent we forgot next time. So let's hit this logout and let's call this sequence control. Bracket. Okay, using this way to call this sequence control program. Okay. And next, we will call the valve control. Currently, valve control has nothing there. Click this login. Once we click this login, the system will download the program. So we will start to test our program, the code. Okay, so now the system should start to run. Let's go to the sequence control and let's hit this start. Once you hit this start, we will see the controller will start to run and the variable will have a value. So the value step number, this sequence step number shows 0. That means currently this case is running this area only, the step 0. I'm going to trigger this sequence step underscore task done 0 to 1. And this will allow the timer trigger. And once the timer expires after 2 seconds, it will turn on this delay done. And after this turn on, it will move to the next step. So to trigger this task done, bracket 0 to on, I need to use the watch table. Okay, so let's go to the PLC window and turn on this watch 1. And at here, I will type in seq, so dot sequence task done. This is the array. Okay, so we can see here. Now I'm going to demonstrate this case, how this case instruction runs. So now it's at 0. It's waiting for this task done to 1. I will turn this index 0 to on. And once it's on, after 2 seconds, this delay will turn on. So we'll see this step move to the number 5. And once it's reached to the number 5, the case will only focus on this area logic, and then we'll turn on this task done number 5 index. So this tag. Once this tag turn on, it will move to the next one. We can see the step move to the next one. So we follow this way, turn on number 10. Okay, now our step is at 15. So from this number, we can see the sequence started at 15. Now it's waiting for the 15 index task done turn on. So it's waiting for this signal. In the meantime, we can go to the sequence conditions. So now we can see the conditions before the 10, they all turn on. Now the 15 is waiting for this task done index 15 to turn on. So it's waiting for this signal. If I turn it on, press this prepared value and click this write values. So the timer, after 2 seconds, this will turn on. We can see this queue turn on after 2 seconds. If we go back to this sequence, now it's moved to the step 20. If I turn on this step 20 condition and watch this number change, okay, I'm going to turn on this 20. If the 20 turn on, after 2 seconds, it will move to the 25. Okay, if the 25 turn on, it will move to the 30. Because here I have a typo problem, so even if this turn on, this step still move to 25, so it's stuck here. I need to change this logic to 30. Okay, here is one typo problem here. So let me change, let me click this log out. So let me change this, so that is the 30. So it allows this 25 move to 30. And after 30 done, it will move to the 0. Okay, let me click and download again. So once we download, it will move to the 30. Now it's at 30. Once this 30 turn on, this 30 task done turn on. So this step will move to 0. Okay. See, after 2 seconds, so this delay done will turn on. Because all this task done signal is on already. So this sequence is run cyclic. So we need to do something to prevent this happen. Especially at the beginning of this sequence, we need to put some condition to prevent this uncontrollable cyclic here. We can do a signal initial at the first step to initial all the signal and the variables. So let me show how can we do this. Firstly, let me hit this logout. So to prevent this happen, we need to reset some bit at the beginning of the sequence or at the end of the sequence. For example, at the end of the sequence, before we jump this step number to 0, we need to reset all those task done conditions. We can use the for instruction to batch reset this task done signal. Firstly, I can declare one local tag at here. That is the index I. That's one integer number. Okay. And here, this tag is just a local, only used within this sequence control. And at here, I can use the for. For example, we want to reset all of those tasks done. So we need to do this. Index number from 0 to the entire array. Because when we declare this array that from 0 to 100, so I need to from 0 to 100 do. This is a for loop instruction, and we can reset. So let me copy this task done. The index will use this. So we give a 0 to this task done. Basically reset all of them, and then we shift to the 0, move to the beginning of this sequence. And at the beginning of the sequence, we can do the similar way. And if we move to the top, the step 0. So before we move to 5, we can reset all of others. But this time, because this is step 0, so we need to reset from 1 to 100. Basically reset the step after this 0 step. So this time we index from 1 to 100, reset them to 0. Once this case move to the next step, that task done will depend on the actual conditions read from here. So we will program the conditions at here. But this initial, we need to reset to 0. Okay. And once we program this, let me log in. Okay. So we can see, because now it's at 0. At 0, it's waiting for this done to turn on. Okay, let me turn on. So after 2 seconds, it turned on, move to the step 5. And at here, so turn on. 1, 2, after 2 seconds, it moved to number 10. Okay, turn on this task done at 10. Turn on. Okay, after timer move to 15. So 15 turn on. Okay, it moved to 20 and 20 turn on. and move to 25, and the 25 turn it on. And move to 30. And now once I turn this on, so this timer will turn on, so it will reset all of those task done bit. So let me turn this on. After the timer, we will see all those true will go to 0. See? All those true go to 0. So it's moved to the top. And waiting for some trigger to turn this task down 0 to on to start this new sequence. So this is the basic structure of this sequence. And after this, we will program the valve control. And to automatically control the valve to move to work or move to home, we can use this step number to control the valve. Since so far this video is too long, almost 40 minutes, so I will temporarily park here. And in next video, I will mainly discuss how can we use those integer, this step number to control the valve go home and go work. Also, I will explain how can we organize the conditions to control the task done, allow the step go step by step. And the next video will be very interesting because I will use those step number to control those valve, and I will explain how can we use this timing chart and use the integer number, the step number, to control those valve work and home. Okay, see you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.